Start? Yeah. Good afternoon, dear participants. In the series of this distance learning program, my second lecture is on digital terrain analysis for watershed characterization and management. In this lecture, basically I will tell you that how digital elevation model, we call it DEM, how it is used for characterization of various parameters of watershed and which can be used for soil erosion modeling, which you can say tomorrow we will discuss soil erosion modeling. Then this parameter is also used in soil erosion modeling. And the parameters we retrieve, that is very much useful for land use planning or planning for soil and water conservation measures. Some of the terrain parameters are required. So how those parameters we can retrieve from GIS analysis using digital elevation models will be discussed in a great detail. If you see that topography or terrain, it refers to the shape or configuration of the land surface, how your land surface appears. It is expressed in the terms of, you can characterize in terms of elevation, slope, and orientation of the slope features. We can generate digital elevation model through contour lines, which is available on Survey of India topo sheets or topographical maps of the region. And this elevation informations help us to know how the surface runoff water will flow and how it will be distributed in the area. So technically, if we see digital elevation model, it is the representation of continuous variation of elevation over the space. So continuous variation of relief, or you can say the elevation over the space, we term it as a digital elevation model. There is another term used, that is the digital surface model. Digital surface model, it is when we are deriving digital elevation model through use of remote sensing data. Actually, remote sensing data provides you the reflectance of the surface, and in the surface it also includes the heights of building or trees or permanent features. So it is known as it is not a pure elevation model, but it will generate you digital surface model. So from satellite data, what DMs are there today, we call it as DM. Basically or technically they are known as a digital surface model. When you are generating with the help of your contour lines from the topographical map, then you can say this is the bare earth digital elevation model, which we call digital elevation model. And with the DSM and DM terms also you will find the use of digital terrain model. So digital terrain models include both the DSM and DM. It is broad terms which is used in general. It where digital terrain model means terrain often implies the attributes of landscape. So on the landscape, any features are there, they are included in the digital terrain model. So it includes elevation plus land surface attributes present on the earth surface. So how this DM can be utilized for deriving the terrain attributes will be discussed. If you see here, I have shown here the contour map, which is generated using topo sheets, and you can say that this is the lowest elevation 580 meter, and as we go upper, this becomes the higher elevations or 2180 meter. And but here you are not getting you are getting the contour lines, but between two contour lines, what is the elevation, what is the height of the land we are not knowing. So there is a gap. So this gap we can fill up through interpolation using GIS, and we can generate continuous land elevation information, and we call it is digital elevation model. Now you see the from contour map this DM has been generated. This is the higher elevations, this is the lowest elevation. What could be the sources of DM? You can say there is a source. We can generate the height map through ground survey. We can generate through airborne photogrammetric data capture, or you can say the 3D stereo data aerial photographs. You can do with the cartographic survey, that is the topo sheets is example. We can generate airborne laser scanning, or through laser scanning height can be generated, informations can be generated, or even microwave remote sensing data, radar based satellite data also used in generating the third dimensions or height information of the land surface. So today various type of digital elevations are models are available, which has been generated from satellite data, optical remote sensing satellite data. And if you see the accuracy, ground survey provide the highest accuracy, and it is used. Even the DGPS, differential GPS system, is also used for this one, or leveling system, and it gives the accuracy, even height accuracy of 1 meter to 1 millimeter to 1 meter. And even the leveling systems that generate the height information with accuracy of even equal to 1 millimeter. Stereoscopic optical satellite data, for example Spot, Aster, and Indian satellites Cartosat, that generate you the elevation accuracy with 10 meter. With 10 meter accuracy, DM Cartodem is available, Aster DM is available, which is providing us 10 meter 10 meter spatial pixel size, and elevation, even elevation vertical accuracy 10 meters we are getting in that one. But aerial photographs, if you generate the DM, gives the accuracy of 0.1 to 1 meter, or you can say 10 centimeter to 1 meter height. Laser scanning, where you can say that we use airborne laser scanners, which is give very precise elevation informations up to 0.2 millimeter, 0.2 meter, or you can say 20 centimeter to 1 meter. Satellite radar imagery through interferometric methods, which provides you the DM and SRTM, which is globally the first DM was generated by US NASA, that is shuttle radar topographic mission. One satellite was launched to cover the entire globe, and it generated the DM of entire globe, and from very beginning we are using this one, and it provides the vertical accuracy of 20 meter to 25 meter. So you can say the DM can be generated, elevation can be generated with the very precise to course 1 as per the requirement to meet our purpose for natural resource management. So what DM are available? So it is given the list of freely available digital elevation model. Cartodem of India, which is having the resolution of 30 to 90 meter. You can download from this website. SRTM NASA, it provides the resolution of 30 to 90 meter. You can get from the USGS Earth Explorer. Aster data, Aster DM, ALOS Pulsar, ALOS Global Digital Elevation Model, 30 meter resolution. You can download from this site. Geotopo 30, which is the 30 arc second or approximately 1 kilometer spatial resolution for global coverage or for global study, we use this one. So various digital elevation models are today freely available of India. We also, ISRO has generated Cartodem of India, and other countries or other international bodies have generated for the entire globe, which can be downloaded. So now comes to the terrain analysis. how we can analyze this digital elevation model to derive terrain parameters. So this has a very advantage of digital terrain models is advantageous, because earlier we were doing the qualitative analysis of your terrain. Now we have moved towards that quantitative analysis, measurements, very precise measurements of terrain parameters. You can store those terrain parameters in GIS. You can update or manipulate topographic data digitally for various applications. You can analyze that one. You can generate 3D view of your watershed, so showing you the different height in the watershed, and for visualization, so that it gives a realistic pictures of the watershed. It provides also you advantage to generate some index or indices, which is very useful indicator for environmental processes study. In terrain parameters, if you say, we can group terrain parameters in three major group. One is the morphometric parameter, where you can say the slope, aspect, and 3D view or view shed. Even we can generate the curvature gradients. So curvature of the slope can be studied, vertical curvature, profile curvature, mean curvature. These things are, these topographical informations provide a very useful information when we generate soil and water conservation measures. So for measures how your topography will behave in accumulation of runoff water, or how it will behave for erosion severe area, by studying the terrain parameters, morphometric parameters, we can analyze our watershed in a very exhaustive way, so that we can generate a very reliable informations to understand various process of watershed. Another parameters is hydrological parameters. Hydrological parameters is one of the most important parameters which we are using in our watershed modeling. That is the flow accumulation, where the flow will accumulate, means runoff water will accumulate, where there will be minimum accumulation, where will be maximum accumulation, and this accumulation pattern in the watershed tells you about the erosion potential due to erosion problem or erosion potential due to its topography. Third parameter is we can also derive the climatic terrain parameters. Means DM gives you idea about the direction of the solar insolation, which aspect of your topography will receive more solar energy, so that their vegetations and other crops will do better, or which side you will get better solar radiation, so that you know the solar radiation is important for vegetation growth. So for agricultural land use planning, this is one of the important parameter. So besides this, also we can use the DM to prepare the landform map. So you know in the watershed, if a hilly watershed is there, we can delineate landforms, for example valley area, top of the hills, side slope of the hills, using digital elevation model, or where there are various semi-automatic procedures are available in the GIS software. You can put as an input map of DM, and you can generate ridge map, ridge, channel, plain, slope, pit, valley, all the land features, landforms can be delineated very easily from the digital elevation model. So it is a very useful useful parameters which can be utilized for land use planning. You see, that is the yesterday I was showing you the how to delineate the watershed map. For delineation of watershed map, basically, or for analyzing the terrain parameters, you need a drainage map. Drainage map, you know, this is the drains, and first order drains, second order drains, third order drains. when first order and first order meets, then forms the second order, and second order forms the third order streams. So various streams which you can map from the satellite data, you can map with the topo sheets, and this you can use this drainage map to prepare the sub watershed map. Okay, watershed, it is entire area one watershed, and its further division is sub watershed. So this drainage map, earlier we were picking up with a topographical map, but now this drainage map you can generate with the help of your digital elevation model. So we will see in other slides. Morphometric parameters, if you see, of the terrain of watershed, we want to analyze the stream orders, streams, drainage density, form factor of the watershed, circularity index, elongation ratio, slope of the watershed or sub watershed, relative relief, means maximum elevation to the minimum elevation of the watershed. If difference is very high, then relative relief ratio is high. Dissection index, how our watershed is dissected. If the area is more, watershed is more dissected or sub watershed is more dissected, it means erosion rate is high. So some of these parameters can be analyzed once you get the drainage map, and this drainage map we can generate from the digital elevation model automatically using GIS software. So I will also show that one, but this terrain parameters morphometric parameters of the watershed can be analyzed. So how we do the digital terrain analysis for watershed delineation? You see that one. You have the digital elevation model, DM, then and these digital elevation models can be input in the GIS software, and various GIS softwares have the hydrological tools in GIS software functionality. If you go, you will get the topographical tools or hydrological tools, and in that hydrological tools you can generate the various parameters which is shown here in the right side. So take the DM, prepare the flow direction map, prepare the sink map, and means it is the process of correction, and fill the where the are there is any sink. If there is a gap area, then you can fill it. If there is no gap area, no depression area, so you can process further digital elevation model. So we can generate flow accumulation algorithm generate, that is where the run of water will accumulate, and this flow accumulation map is used to generate stream order, first order stream, second order stream, third order streams. So streamline, stream link you can generate, and this can be used to prepare the watershed map or sub watershed map. So basically for watershed and sub watershed delineations, you need to generate the your streamline map, and that can be generated with your from DM directly. How so in this how flow direction and flow accumulations map are generated, and how the stream order will be generated, that is explained here. Because flow direction, suppose this is the digital elevation model where height map is stored in a pixel form, and when this elevation map we run, we generate the flow direction, and flow direction, it is showing that is the change in height value with respect to the distance, then we calculate the flow direction. So flow direction, it is calculated in the, you see the in 8 directions, so we call it is D8 flow model. So in all 8 possible directions, flow will be determined, and it will find where the lowest elevation, where there is a lowest elevation, from lowest to highest water will move. Okay, so by that one, then which pixels it will move first, then it will coded as a 1 2 3, or so that you can get the flow direction map. If you see here, so flow directions, if you see it coded as a 1 2 3 4, and then you can see this is it is showing the direction how the water will flow after the rain, the runoff generated, then how runoff generated will flow. This is the flow direction. And to extract the drainage network, then we give the threshold value. We define the threshold in the software, and then it delineate the drainage network. How it does? Because flow accumulation, it calculates the accumulated flow. It calculates, that is, a particular pixel is receiving runoff water from how many pixels. So the value what you will get in this 4 5 what you are getting, it means it is getting the runoff water from 6 pixels. Suppose 6, it is getting from 6 pixels. And then high flow accumulations are areas, so where you are getting more numbers, so it means this is the area, suppose 16, so it is getting 16 number of pixels, so it is the depressional area. And if it is depressional area, then there will be concentrated flow from this side. So from here, suppose 9 16 20 26, it means water will move from this 5 9 16 20 and 26, like this one it will move. So we can get that it means this area will form the gully. There is a more chances to form the gully. So, and water will flow in this one, you can say it is concentrated flow. And this if you link these pixels, then it will form the stream channel. So by doing the flow accumulation, flow direction, flow accumulations, you can generate the drainage network map. So you will be able to generate like this one, drainage map. And so first order, second order, and then linkage. And how we will generate the first, second, third order, it depends on the what threshold value you define to it. So threshold value for permanent feature, threshold values are more number. So we will show that is the how threshold value is changing, and your drainage pattern are differently delineated from the using flow direction and flow accumulation map. So basically, once you get the drainage map, and this drainage map, you then through software you can generate the sub watershed map. So threshold value, you see, that is, suppose we have extracted the flow, we generated the flow accumulation map, it is zoomed one of this one, and suppose you are getting lot of drainage patterns, drainage lines. If you put the threshold 100 and you have put the threshold 1000, so you are seeing here less number of drains. So if you are increasing the threshold numbers, means it means 1000 means, if I am setting the 1000 means extract only those pixels which is receiving the runoff from 1000 pixels. If I say it is 500, so delineate those drainage lines which is receiving the runoff water from 500 pixels. So if you compare, as the threshold value is increasing, drains are decreasing. So you can say the major drains, if you have to delineate, then you have to increase the threshold value. So by changing the threshold value, we can generate the first order stream, second order stream, and third, fourth, like that one. Once you get this order stream, then we can give the numbering system also. And there are two type of numbering systems are there: Streller system, stream system, and Shreve stream ordering system. In this one, for example, first order gives the second order, second and 1 gives the 2. But here in sieve ordering system, first and first give 2, but 2 plus 2 second order and first order they give 3, but here it gives 2. So this two different type of ordering systems are used. So you can in general stellar stream ordering systems are used for characterization of the watershed, drainage patterns in the watershed. So once you get this one drainage lines, then you can go for the delineation of the sub watershed. You can divide and you can. So for delineation of the watershed, then you have to define, that is the point, that is the outlet. You can define a outlet that the entire area should drain where. Suppose this is the, if you define here, then it will delineate like this one. But if you define the outlet points physically by point map, you can define here that here the joint is there. So for this point you generate the how much catchment area or upslope area will be there. Then system or computer program itself, software will identify the watershed area based on the height map, because seeing the adjoining pixel height, elevation height, it will generate the sub watershed boundary map, and then so that in this way you will able to generate watershed map, sub watershed map. Then comes, that is the, in the watershed we are interested to know about the slope parameter, and you know this is the slope, how we can calculate. Then actually algorithm calculate the difference in height or difference in elevation in x direction. So dx map, for example, if you calculate the height difference in y direction, so in y direction height difference, then you can generate the dy map in y direction and x direction, and then you, with this one you can generate the slope map. So the formula which uses this one, suppose x direction difference and y direction difference and difference of height, then arctan of that is calculated and you are able to calculate the slope map. So if 45 degree slope is there, it means it will generate the 100% slope, because arctan or tan 45 degree is equal to 1 or 100% slope. So more than 45 degree, all slopes are considered as a 100, more than 100. That's why in digital elevation model you will also get more than 100 or 300 slope class, although in nature we know that is maximum is 100%. So what is the slope? You can say in the difference in height, elevation in x and y directions, you can calculate using dm very easily. Then comes the another parameters of the watershed is your aspect map, means exposure of the sun surface, sun radiation. So aspect, you know, that is the, if you see, that is the clockwise 0 to 360 degree of any hill. So you can say 0 to 45 is northeast, then 45 to 90 degrees east, and 180 is south. So in this one we can calculate the aspect map and generate north, northeast, east, southeast, and various direction map you can generate from that water for a digital elevation model. So you see, this is the green color is showing south, southeast, where is red is showing the north. So red is showing the north means in this side, that is you are getting the minimum solar radiation, minimum sun exposure, but in the southeast or in the south you will getting the maximum sun exposure. So these things are important to study the vegetation growth, even the crop land use planning or vegetation land use planning. This aspect informations are required to know. Then comes the another parameter is your curvature. Curvature means you can say the how the shape of the slope is there. So you can see here the slope. So in the slope you can see that is this is the profile curvature and this is the contour curvature. So profile curvature, this curvature is the second derivative of the slope of the slope. We call it a second derivative. Slope and aspect is the primary derivatives. And this if you calculate the curvatures, then it helps us to understand erosion and runoff processes. So it is used to better characterize. So if you want to study the erosion patterns controlled by topography, then curvature map are generated, and there is a two curvatures which is commonly we extract using GIS, that is profile curvature, which is the direction of the maximum slope, profile curvature direction in the maximum slope, and plan curvature, that is the perpendicular to the direction of the maximum slope. So its perpendicular is calculated as a plan curvature, and profile curvatures give you information about acceleration and deceleration of flow, means how flow movements will be, how fast will be there. It gives, so higher the profile curvature values means there will be more speedy flow on the topography, and plane form curvatures give you the convergence where the flow are meeting together. So it means if they are meeting together, it means there will be more concentrated flow of runoff water. So it will tell you about there is a chances of gully formation. So here you can see that is the when the runoff water is converging, so meeting together, so there is a chances to high means gully formations, where here is the divergence or runoff water is moving away, so there is no, there may be more real erosion in this area, but here you will find the gully erosion. So plan curvature and profile curvatures can be used for analyzing these things. Another important parameter is that we can use digital elevation model for generating terrain indices, and in terrain indices, which is the most commonly used for the hydrological parameters, that is the flow accumulation and flow accumulation map, and this flow accumulation map gives you idea about the hydrological parameters. But beside this, the three indices are used. One is the compound topographic index, CTI. We also call it wetness index, and wetness index gives you idea of the spatial distribution of zones of saturation. So where the you are getting the high CTI value means there is a chances of more accumulation of runoff water. So it gives that is that will be the wet area, and that you can use to identify where water harvesting site can be generated. So topographic index gives you a very good idea about rainwater harvesting site, as well as the area which is receiving more water. So because of that, their vegetation planning can be, or land use planning can be done. And another is the stream power index, and third is the sediment transport index. You see the sediment how 1 minute. Stream power index gives you idea about suitable location for soil conservation measures, whereas the sediment transport index gives you idea about erosive power of overland flow, means how the stream water will, with how much velocity it will flow, so that if you are getting high sediment transport index, it means there is a chances of more erosion, or there is a chances of river side river bank erosions you can expect there. So this you can analyze with the help of your DM. So what the formula we are using in this calculation, suppose this is the CTI, or we also call it is a terrain wetness index, It is the natural logarithm of AF. What is AF? AF is the upslope contributing area, means flow accumulation area. So it is a flow accumulation area, AF you can say, and then tan beta means slope, beta is slope. So tangent of slope can be used, this is simple equation can be used to convert, that is your TWI. Stream power index is the function of AF into tan beta. And third is the sediment transport index, which can use, is the formula is AF, or that is the flow accumulation area divided by 22.13 to the power 0.6, and sine beta or sine theta or slope divided by this and to the power 1.3. And this sediment transport index, which can be later on it was used to in our soil erosion modeling, but it gives you a very good idea about the sediment transport index, means where the sediment transportation will be high due to topography. So we can see that is the some examples how we can generate using digital elevation model these terrain parameters, how we can utilize this one. You see, this is the digital elevation models of one watershed is given. This is the lowest area, or you can say the outlet point. Drains water is draining from here, and this is DM is reflecting like a drainage map, and from this one you can generate the flow direction map, means how the flow will moves in that one. So we can generate directly flow direction map. You can see from flow direction map and flow accumulations map, if you give the threshold value, we can generate the stream map. So first order, suppose this is the first order, this is the second order, and this is the third order streams. So all the order streams can be generated from the DM by providing the suitable threshold value. So you can see here the threshold value effect, how they are changing. So this is the threshold value has been given. Here is 250, 500, this is 750, this is 1000, 1250 and 1500. So 1500 threshold value is giving you the major streams. But if you are giving the 500 threshold, then you are able to extract the first order stream as well. So by providing the thresholding, you can generate the various stream drainage network, first order, second order, third order, which can be used for morphometric analysis of the watershed. You can generate the slope map, aspect map, and this is the generated the terrain wetness index map. I told you the terrain wetness index map. This index maps give you a very good idea, that is the higher the value will show, that is where the most of runoff water accumulation or saturation zone. So the you can say this red value is more than 8. So this red is showing this water is flowing on this line. If water is flowing in this line, it shows that is if you want to construct the rainwater harvesting site or ponds construction, then you can plan on this land area or on this suitable size, because you know now the how much it is contributing area is there. Also you can find out, and suitable size of conservation rain harvesting structure can be put. But another point it is showing, that is suppose it is showing the green color, which is showing this area is receiving a good amount of water, but your blue color is showing, if you are seeing that is the blue color less value is less than TWI value is less, then it is showing on the ridge area. So ridge area where you will get the water will not accumulate here, water will move from here. So this area land use cover may be different one, So according these informations we can utilize for generating suitable land use plan. Climatic terrain parameters, as I told you that digital elevation models give you idea about the that is where the solar radiation is reaching very high amount, so that you can say their vegetation growth will be better. So this red area is showing high vegetation, high solar incoming solar radiation, and these are the area where the minimum solar radiations are coming. So this area are the mainly the perennial vegetations or natural vegetations, they may flourish, but in this area you cannot go for agriculture planning because these are not receiving the high sun radiation. I told you that is one of the important parameter we use to extract for our soil erosion assessment is LS factor, and this LS factor, you can say L means slope length, S mean steepness of the slope. So length of the slope and steepness of the slope both together known as a topographic factor. So this factor is used to is a very useful parameter which we can extract from DM directly, that we can put this map directly into the various erosion models where we want to estimate the soil erosion estimation, where in another lectures we will see that one, how important is LS factor. In the LS factor, you can calculate where input parameter is required, the flow accumulation map. And I told you in the previously that flow accumulation map, if you generate, it will provide that is which pixel is getting highest amount of which pixel is getting how many runoff water from how many pixels. So pixel number shows that is the number of pixels it is receiving. Suppose there is a 10 number, so 10 number and pixel size is 20, then 10 pixel it is receiving water from 10 pixels, and if your pixel size is 20 meter, you multiply, then it becomes 200. So 200 will be the length of the slope. So slope of the length we can also calculate with the help of your flow accumulation map. So we take here flow accumulation map, grid size means pixel size, multiply by pixel size, divide by 22.13 and to the power 0.6. How 22.13 has come? Tomorrow I will show that is the in the erosion models empirical equations this value was taken. So it is generating the constant for that one. So 20 divided by 21.3 and 0.6 to the power and sine slope map, and to the power 1.3 we can generate the LS factor map. So this LS factor map, although if you go without GIS analysis, manually if you calculate for any field length or slope, length of the field, L means length of the field and L factor, S is the steepness factor, then it is very difficult parameters to calculate for entire watershed. And here by DM, use of DM, you can generate the flow accumulation map, you can generate the slope map, and taking these two maps you can generate the LS factor map. Another examples how useful is your digital terrain models are there. We also use digital terrain models for soil erodibility mapping. Soil erodibility mapping, because you know the soil some soils are erodible, very easily get eroded, some soils are not so easy to erode. So erodible means in the watershed which area is most erodible and which area is least erodible, that can be studied with the help of your preparing the soil erodibility map. And preparing this erodibility map, we did one analysis that suppose this is the points showing the soil sampling sites. So from you take the soil samples of surface layer at a regular grid interval and you know all the soil properties. Here you know the soil texture and organic carbon and other soil parameters. So you can calculate the soil erodibility. So every point I can calculate the soil erodibility, and this soil erodibility, this point map can be generated as a continuous soil erodibility map. You see there all the gaps are filled up, and we use the terrain indices, that is I told you earlier, terrain wetness index TWI, this map generated from DM, and slope map generated from the DM, and both the maps can be integrated through equations, and by by developing the multiple linear regression equation we can generate the soil erodibility map. So you see where you are getting the higher value, that is the suppose, yeah, this darker value is showing that is the lowest soil erodibility, and the green, this value green is showing the highest soil erodibility. So in a watershed this green area are highly erodible soils, soils are highly erodible. So you can prepare a which area of the watershed, soils of which area of the watershed are more erodible, that can be easily identified, or we can map with your digital terrain models. Another advantage of digital terrain model is that we can use, for example, you have taken the soil samples, here in the grid samples you analyze the soil carbon of each point, then we can use to generate the soil carbon distribution map. Here you see here we have used the digital elevation model, terrain characterization, and we generated the slope map, terrain wetness map, and soil samplings. Then you can generate for each point total carbon, nitrogen, phosphorus, and these maps can be integrated, and using the geostatistical analysis where kriging and co-kriging methods can be utilized, and we can generate the spatially distributed organic carbon, nitrogen, or phosphorus map, or whatever the properties map are there. So you see that is the organic carbon distribution map was generated, where you are getting the this reddish color means here organic carbon is high, and these are the yellow color, the lowest amount of organic carbon is there. So soil organic carbon map can be generated, and you know this carbon map is also required for the soil carbon stock assessment, or soil erodibility assessment, or even soil fertility map generations. This organic carbon map can be utilized. So I can say that digital terrain models can be used for analyzing various terrain parameters of watershed. As in the beginning I told, for the watershed characterization we need to extract the drainage line or streams, and DM by generating flow accumulation and flow direction map you can generate the stream index, stream patterns use, and these facilities are available in most of the GIS software which is available today. Either it is freely available or it is paid one. All GIS softwares having this functionality of a hydro processing of digital elevation model. Then we have seen that is how we can generate the slope map, aspect map, how you can generate the that is your watershed map, sub watershed map, and even we can use some terrain indices generating, and that can be directly utilized to interpret the area of the water accumulation. I told you in the terrain wetness index, and also in the stream power index to find out the stream power erosivity. So those things can be analyzed very easily using digital elevation model. So we can summarize that this these digital elevation models which is available today from various sources with with high spatial resolution of 10 meter is available. Indian Cartodem 10 meter and 20 meter, and most of the global global digital elevation models are available at 30-meter resolution, which you can download from the internet, and that can be utilized. So, and these are very compatible with GIS analysis. It provides you understanding, quantifying, and describing the nature of topography even at inaccessible area. So in the hilly area, the most of the area are inaccessible. So for generating the terrain parameters to analyze the runoff or analyze the soil erosion loss in inaccessible area, this terrain DM derived terrain parameters can be utilized. It helps in the faster derivation of the topographic attributes or morphometric parameters. Earlier, for generating this information, so many of terrain maps, it was very difficult process, and it is also you are not able to generate so many maps for analyzing the watershed in a greater accuracy and perceiving that one. Many of the erosion models, hydrological models, geological models, all are requiring this terrain attributes map for generated from terrain analysis, and it helps in better understanding of the topographic control over earth surface. So DM is not restricted for the watershed management only. You can use the terrain parameters for vegetation analysis, for geological analysis. You can use for soil mapping or soil nutrient mapping, soil fertility mapping. Today, lot of DM derived and input parameters are being used for the digital soil mapping approaches. So it has plenty of scope and utilization of that one, and you can do this analysis very easily from using the any GIS software. So I am giving some you examples of some softwares where you can do this analysis, and this is a free open software, open source softwares. Grass is one of them. You can download from this website, so you can go and download, and there you get opportunity to analyze the digital elevation models and also image processing and other GIS facility. PC raster, QGIS, also known as a quantum GIS. It is one of the most popular open source softwares being used by researchers and faculties, and it is very simple, very easy to understand. And this softwares you will get a very good manual and data sets also available with that one, so that you can do your terrain analysis, erosion model assessment and watershed analysis very easily, and you can understand those process. ILVIS softwares, it is the one of the very good software for education and research purpose, that is integrated land and water information system, ILVIS, and it is can be downloaded from your this websites. Saga, UDIG, there are various softwares are there, but I will recommend that for you. Anybody want to try, then QGIS, GRASS softwares, ILVIS softwares are widely being used by the researchers in their research program. Thank you very much for listening these lectures, and I will take another lectures on soil erosion modeling, where you will use this terrain analysis for soil erosion assessment. So tomorrow and today, if any questions you have, you are most welcome. Yeah, questions from uh, one: how DM can be used during flood cases and watershed during natural calamities. Actually, DM, it provides you information about the slope, and it also provides information about the lowest elevation and highest elevation. So depressional area or valley area can be delineated using DM. So in the flood, the lowest elevation area it will follow, and what will be the height of the flood will also can be determined using DM. So DM, from the DM, the derived input parameters are used in flood modeling. So you know that if the slope is more, movement of a run of water will be high. So how much slope percentage is there, what how much area under depressional land or valley area, these informations are very useful for flood modeling. So DM is a important ingredient, input parameter of flood modeling. And watershed in natural calamities, watershed, that is the suppose natural calamities are drought, or you can say the landslides, landslips, or where more of the runoff water is flowing, because of that flash flood type of situations also created. So DM is a very important, even the suppose for drought in flood and watershed, lowest elevations or valley area, or where the I told you the topographic index TWI, where you are getting the high value means that area will get more moistures. So there you can generate the more runoff water, that area will get more runoff water. So there you can rainwater harvesting structures can be constructed, so and you can mitigate the drought. So like that one, this DM is a you can utilize for that. Share the list of websites, as we didn't appear all websites during online session. uh, List of websites, I think websites, that is our lecture PPT, the websites in the slide presentation, it is there, so you can see carefully and you can note down by holding the slide. Use of two numbering system, yes, there are two numbering system are there, and I told that Stellar and Sriv. Stellar is the most commonly used numbering systems, and which is being used in India for putting the first order, second order and third order streams, and for watershed characterization. So you can go for Stellar ordering system. DM and DTM difference, as I told you, DM is a when the it is purely absolutely the earth surface elevation. DM is earth surface elevation, whereas the DTM is includes elevation of the earth surface as well as any features above on the earth surface. For example, you have a building or you have a tree and over the earth surface. So for that place where the building is there, if you take the digital elevation model from the your satellite data, then it will include height of elevation of the earth, bare earth, as well as height of the buildings or tree. That's why you can say DTM includes both elevation of earth surface as well as buildings or any earth features, but in DM it is absolutely bare earth surface elevation. He asked, that is how we can decide the threshold value. As I told you, the threshold value, if you are increasing the threshold value, then threshold value means what? When we are saying that is suppose threshold value 500 and threshold value is 1000, it means 500 if I is saying, then it will take all those pixels in it will display all those pixels which is receiving runoff from it is showing the receiving the runoff more than 500 pixels. So as you know that the pixel is showing that it is receiving how many pixels, suppose 500, 600. So if I am saying 500, then more than 500 any pixels is receiving more than 500 runoff water from more than 500 pixels, it will include in that one. So you can say the lower the threshold value will show more drainage pattern, and if you are increasing the threshold value, suppose you are saying 10,000, so it will show only those pixels which is receiving runoff water from 10,000 pixels and above. So you can say the first order streams you go for the lower threshold value, but how, what will be the value decide, you go for the just setting one after another, and by permutation and combinations you can find out that is what will be threshold value, you can find out. It depends on the elevations. Okay, on what basis the threshold value is given, on how streams ordering is given. So I just explained you threshold value. You can say again question is there, means number when we prepare the flow accumulation map, flow accumulation map shows the numbers, and number shows that is this pixel is getting, or this pixels will receive the water from how many pixels. So and if you set 500,000, 1,500, then you can extract more variable variable numbers of the you can say the pixels will be extracted, and those pixels is known as a if those pixels are connected, then it will appear as a stream. So this threshold value for if slope area is less, or if your elevation variation is less, if your variation is less, then you can say that is a threshold value will be different than the steep sloping area. How many values are added further in flow accumulation matrix? How value are not added. Software itself, when process the flow accumulation map, it gives the, it assign the pixels based on the based on the neighboring elevation of the pixel. It calculates in considering the 8 direction, that is this particular pixels will receive runoff water from how many pixels. So you can easily so it assigns the number of number which denote that is it is receiving the runoff water from how many pixels. Okay, so this number is not assigned, but it is automatically calculated. How DM data, so DM data can be used for the terrain parameter characterizations, and flood models directly needs those terrain parameters. So you can use this DM derived terrain parameters for flood modeling or flood analysis. For preparing top line watershed, where we get the real time Z value. Z value is means the elevation of the point, height of the point, and height of the point I told you can generate by stereo aerial photographs, even you can generate by the DGPS survey or ground survey, or in remote sensing technology we use optical remote sensing data where stereo satellite data are there, or by processing stereo satellite data using photogrammetric software, for each point, each pixels we generate the height map, and this height map is known as a elevation map or Z map. So microwave satellite data also you can generate the height map, and optical remote sensing data and topographic data, and if you want I show you the contour map also, which was generated using topographical maps. Is it possible to extract GCM data for a watershed using GIS? GCM global circulation model. Global circulation model is a climate model where we generate the scenario for climate, future climate scenario. So future climate, it is a, you can generate the climate scenario for your watershed. Okay, means any weather stations, but here you cannot directly say like that one use of DM. QGIS softwares, it is a yes, you can use QGIS softwares directly, but I have not shown any using QGIS. It is analyzed with ArcGIS and ILWIS software. What is the difference between aerial photography and satellite image? You know, the aerial photography, when aircraft having the sensor or cameras and pick the picture of the earth surface, then aerial photography. And when you are taking the pictures from 800 kilometer above the earth surface, that is the remote sensing satellites in general operate 7 to 800 kilometers, then it is satellite image. Are how to create DM in GIS? DM you can directly get from the web resources. I told you the websites. Indian regions, you can get the download the DM from ISRO's Bhuvan portal. In Bhuvan portal, DM is available. So any part of the country you can download, or any part of the world. Other global DM also, Aster DM and other DM also, you can utilize that one. Watershed management to prevent forest fire, sure, because watershed means, when we say watershed, means it is the land area where the soil, water and its other resources, because forest is the part of the resource, so it is used for that one. If forest fire is there, then it is not directly related with the watershed management. Forest fire doesn't come for the watershed management, but you can say that is the you can it is not used for the preventing of forest fires. What is contour lines? Contour line is the line joining the same height or line joining the same elevation. So same heights join, a line joining the same height is known as a contour lines, and these contour lines you can generate if you have the height map of your area. Can DM help in measuring discharge of watershed? Not the it is not directly help to measuring the discharge, but discharge, you know, that is the velocity of the velocity of the run of water or flow depends on the slope gradient. Means in a watershed, the lowest slope, lowest elevation and highest elevation. So rate of the velocity is vary with because of the that you can calculate using the slope information. But discharge measurement you can do only with that your equations, discharge equations are there, where the slope and other parameters or watershed area are taken into account, watershed length is taken into account. So you can use the discharge formula for that. Can you show how we can these softwares prepare catchment? You can do with the thresholding and extracting drainage patterns, and then defining the outlet. If your outlet, you are deciding that here is the all the drains are coming and putting there, so you can generate its catchment area. How can we remove artifacts heights from freely available SRTM or ESTER data? So artifacts trees, you can, it is very difficult to remove that is artifacts height. Sometimes suppose you are knowing that this area having forest of equal height or almost the same height of that one, suppose 50 meter or so or 30 meters, so you can subtract 30 meter. Or suppose you know that is the vegetation map of the area, or and different height map, you have vegetation height you are knowing, so that polygon you can make a polygon, and you can subtract from there SRTM DM, and you can make a bare earth DM, but it is not so easy. Why use ILVIS software and how important for me? ILVIS is a software, GIS software, image processing and GIS software, both functionality is there. and this software is very easy to use and very mathematically very strong, where you can apply all mathematical formulas there. So it is for research and scientific purpose. It is one of the good GIS software which is being used by that by those peoples. How you can calculate slope? It is very easy. If you take the DM, put as a input into the hydrological processing software, there is a direct option is there. You can generate the slope map. Otherwise, the formula how to this algorithm use the formula I have shown you there. So different softwares algorithms are written to calculate for each pixel the slope is calculated. Can we use GIS remote sensing on mountain region? Yes, you can use remote sensing for plain region to mountain regions. GIS can be used in any region. There is no restrictions. You will get, although in the digital elevation models are very much useful for mountain region. How can we predict rainwater harvesting system? No, I told you the DM is used to find out the terrain wetness index is one index. It shows that is where water getting accumulated. So the point where you are getting high terrain wetness index value, that area, it means there water will move from that area. So there you can construct the pond or any tank for collecting the rainwater. How can we remove the artifacts we have discussed already? How to measure soil quality elements? Soil, I have not discussed the soil quality in this lecture. Terrain analysis is useful for reducing forest fire. Actually, you know the forest fires where it happens in the ridge area where the dry zones are there. So terrain wetness index, you know that is the where the high wetness value is very low. There is no wetness or dry area. So dry area you can find out with the terrain analysis, and that if that area lying along with that area forests are lying, then there is a more chances of forest fire. And where there is a wetness area, more wetness, the topographic wetness is more, then you can say that area will be more vegetation growth will be there, and that area having more moisture, so less forest fire probability will be there. So you can link that one, that is terrain parameters with the forest fire. uh, One question that sedimentation deposited in the outlet can be interpreted not directly, but you can terrain analysis you can find out that is which part the sedimentation will there more chances to collect the sedimentation, where sedimentation deposition will take place. So you can say that I told you the stream power index and terrain wetness index, by integrating both you can interpret it, that is which area will receive more sedimentation because of depressional area, and which area is upland area where you can expect less deposition or no deposition. So by terrain analysis you can do this one. LOS pulsar has 12.5 meter spatial resolution. Yes, this DM you can utilize for the watershed delineations and flow accumulation. Even the Carto DM of India, which is available at 10 meter resolution. So today various resolution satellite data are available, DMs are available which you can utilize. Can land degradation can be considered as a land deterioration? Land degradation, land deterioration is same, but not the same. You can say deterioration is a wide term. It may be deterioration because of the vegetation and other parameters, or soil quality or land quality parameters affecting the production. So land degradations, when we talk, then there is a degradation because of water erosion, salt affected soils, or chemical degradation, physical degradations like that one. Suppose I told you the land degradation, vegetation degradation is not included in that one, but land deterioration, that may include your vegetation degradation itself. It is asked that is a LS factor formula calculated manually or automatically. LS factor will be calculated automatically using GIS software, where you will put DM as a input parameters. So you can generate the sediment transport index, which represent as a LS factor. What is the use of remote sensing GIS in civil engineering? You should know that civil engineering peoples are very much using remote sensing and GIS, and terrain analysis is one of the important derivatives or informations which we are using GIS civil engineering for dam constructions, even for the sedimentation process studies, and hydrology. You are studying watershed hydrology, and watershed hydrology is entire digital terrain analysis is required. So it is very useful for civil engineers. Develop a stormwater drainage system map using DM, existing LULC map, and land suitability analysis. I think we can close it because most of the questions have been covered. Thank you all for joining this session, and I welcome you again tomorrow at 4 p.m. same time. We will discuss, that is, how we can use remote sensing GIS for soil erosion assessment. Thank you all.